So as we move from one element to other element, that is lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine, the atomic number increases by 1, hence number of valence electrons also increases by 1. Okay. Or we can say that atoms of different elements with the same number of occupied shells are placed in same period. Sodium, magnesium, aluminum, silicon, phosphor, sulfur, chlorine, and argon belong to the third period of the modern periodic table. These all belong to third period of modern periodic table. You can see these in third period here. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Is it right? Chlorine, argon. So how many orbits should be there now? Can you tell me quickly? If they belong to third period, how many orbits should be there? Very good. Here you can take period means number of orbits. Very simple. Period means what? Period means number of orbits. That's all. Nothing more than that. First period 1 orbit, second period 2 orbits, third period 3 orbits, and so on. Okay. Next. Since the electrons in the atoms of these elements are filled in K, L and M shells. 3 orbit means which shells? K, L and M shells. Write the electronic configuration of these elements and confirm the above statement. Confirm the above statements means what? You have to confirm this. Number of valence shell electrons increases by 1 unit. This is what you have to confirm. I will show it for 2 elements. Remaining elements you have to take as homework. You can do that easily. Sodium. We'll take sodium first. What is its atomic number? Its atomic number is 11. Sodium atomic number is 11. Then what is its electronic configuration? You have already written. Do you remember? 1s square, 2s square, 2p6, 2 plus 2 4, 4 plus 6 10, 1 is remaining. 2 plus 6 means second subshell is filled. Sorry, second shell is filled. Now I have to write here 3 S 1. 10 plus 1 is 11. So kth shell, L shell, M shell. Next is what? Magnesium. As you wrote the electronic configuration for lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine, you have to write here for sodium, magnesium, aluminum, silicon, phosphorus, sulfur and chlorine. So what will be for magnesium now? Electronic configuration. 1s square, 2s square, 2p6. Here Z is tall, no. So in the third cell, you have to increase electron by 1 unit. Aluminium 1s square, 2s square, 2p6, 3s square, 3p1. Because after filling 3s, once again you have to draw the arrow mark from here. It will pass through what? First 3p subshell. Then you will be having here 4s square. Is it right? So before filling 3p, you cannot go to 4s. That is what is the meaning of this arrow mark. So after filling 3s, you have to fill 3p only. So remaining 1 electron you have to place in now p subshell. That is what we have done here. 3p1. What is atomic number of aluminum? 13. If you have any doubt, you can refer to periodic table. Aluminum 13. Can you write for silicon and then phosphorus and then sulfur, chlorine and argon. So what we will have here next? Up to this point, same thing. 3p2. Up to here, same thing. 3p3. 3p4. Same thing, comma, 3p5. 3p6. So at argon, third shell is filled. 2s square, 3p6. 2 plus 6, 8. There are 3 orbits. Here I have to write 3. 3s square, 3p6. There are 3 orbits. Outermost orbit is now completely filled. Completely in the sense 8 electrons are filled. Actually, outermost shell can hold 18 electrons according to 2n square formula. Third shell can hold 18 electrons. But what is another rule there? Outermost shell should not have more than 8 electrons. So once 8 electrons are filled, you have to stop there for outermost orbit. So these are the electronic configuration for all the elements that they have given there in your textbook. And you can see in the outermost orbit, number of valence electrons is increasing by 1. Number of valence electrons is increasing by 1. Right? Have you understood? Okay. Just add one sentence here. Yes. In third period also, we find number of valence electrons increasing by 1 when we move from left to right. Left to right. Completed? Okay. Now, there is one simple question. How many elements are there in the first, second, third, and fourth periods? Right? First, second, third, and fourth periods. How many elements are there? Looking at the periodic table, can you tell me how many elements are there? Can you not tell it? Very simple. First period, hydrogen, helium only. First element, hydrogen. Second element, helium. Only 2 elements are there. Why it is so? Because elements in the first period will be having only one orbit. Only one orbit. First period elements have one orbit. that is K shell. And how many electrons you can place in one orbit or first orbit? Two n square equal to 2, 1 square equal to 2. Since number of orbits in first period is restricted to 1, and by 2n square formula we can place only 2 electrons in first orbit. For the first element in first orbit 1 electron, half filled. For the second element, number of electrons is equal to 2, completely filled. Now you cannot place one more electron in first orbit. Its capacity is over. If number of electrons increases by 1, then you have to take second orbit. That means you have to move to the second period. So first orbit will be having only 2 elements in it, not more than that. Now can you tell hydrogen and helium? This is for first period. Now can you tell what about second period? Period. Period. Second period. Second period elements have two orbits. That is kth shell. Yes. And M shell. Sorry, L shell. K and L shell. K, L, M, N, right? Not M shell, L shell. So how many electrons will be there? 2n square. For first orbit, 2 1 square 2. For second orbit, 2 into 2 square, you get 8. 8 plus 2, 10. 8 plus 2, 10. Is it right? Out of these 10 electrons, 2 electrons are used to fill first shell, that is K shell. And remaining 8 electrons, these are used to fill K shell. And these are used to fill L shell. 8 electrons are used to fill L shell. And the second period starts from second orbit filling. Second orbit starts from second orbit filling. That means third electron onwards. So from third electrons onwards, you have to count up to 8th electron, like this. Third electron, fourth electron, fifth electron, sixth electron, seventh electron, and 8th electron. Right? If you count, I'm sorry here. From third electron, you have to count up to 10th electron because there are total 10 electrons, right? Third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So total how many? 5 plus 3, 8. That means in the second period there will be 8 elements. In the second period, there will be 8 elements. Second period has 8 elements in it. 8 elements. 8. What about third period? Third period means third orbit will be existing in elements. First orbit, 2 electrons. This is number of electrons. By using 2n square formula. This is first orbit. Second orbit, using 2n square 8. Third orbit, using 2n square 18. But how many elements I can place there? Because third orbit is outermost orbit. Third orbit is outermost orbit. We can place only 8 electrons. So I have to write here 8 only. Total number of electrons is 18. But third orbit can hold 8 electrons only. So in third orbit also you will be having 8 elements only. Because third orbit will start from 11th electron. 2 plus 8, 10. After that 11. It will start from 11th electron and it will go up to 18th electron. Total number of electrons is 18 here. So 11, 12, 13, 14 up to 18, if you count, you will get how many? 8 electrons. That means 8 elements will be there. You can verify that here. Now, third period, 1, 2, 3, 4, 5, 6, 7, 8. Atomic number is 18. That means total number of electrons in third orbit with 8 orbit placed in third orbit. With 8 electrons placed in third orbit will be having how many electrons? 18. Because first orbit 2, second orbit 10 plus third orbit 8 only. 2 plus 10 plus 8, that becomes 18. So the third orbit ends with atomic number of 18 and there are only 8 elements. Okay. We're getting late now. Fourth period. In fourth period, how many elements are there? This question you take as homework. I'll stop here and continue in next class. That is tomorrow morning, once again 6 o'clock you want? Is it okay? No, not okay. Then tomorrow at what time I should take? 5:30 to 6:30, is it okay? 5:30 to 6:30. Tomorrow evening 5:30 to 6:30, because some students are having classes starting from 7 o'clock in the evening. For them it will be difficulty. right? So some adjustments will go on making. Tomorrow class will be at what time? 5:30 to 6:30 p.m. I have given the time here, right? Okay.